All right, so here's our last section in chapter 6. We're going to use what we learned yesterday about the end behavior in this section. So keep that in mind. We'll kind of refresh your memory a little bit on that when we get there. But let's first talk about what the zeros are. So if I was asking for the zeros, these are already factored, but we want to know what are the solutions for x. What would we do? Yes.
Make it so it's equal to 0.
Yes, we're going to set each of them equal to 0. So if we set this one equal to 0, what would we get? And so we would get 1 for an answer.
Yeah.
X plus 4 equals 0. We subtract 4 on the other side. We get negative 4. So you're just setting each of the parentheses equal to 0 in solving. Okay, we're ignoring the exponents for now. We'll talk about that down here at the bottom. What would the solution be for this one?
3.
And negative 4. Okay, what about right here?
0.
We take 3x, we set it equal to 0, divide by 3, we get 0. Positive 3. What about here?
1/2.
Negative 1/2. You would subtract 1 and then divide by 2. Questions? Okay, here's what the exponents on them mean. If you have an even power on it, so for instance this 4 right here, it's going to bounce on this number and the odd ones are going to go through that number. It'll make more sense when we see a picture, but just know that is the rule of thumb. If there's an even number, it bounces and it's going to go through on the odds. Here's what I mean. Okay, so here's an example. We need to figure out what the zeros are, or what the x-intercepts are. So we've got a 2 for this first one, right? We all agree? Okay, so on the x-axis, we're going to put a dot on 2 because it's going to touch the x-axis on these points that we're finding. Also on negative 1 and negative 3. Okay, so the polynomial is going to touch the x-axis in those 3 locations. Now, I said that even powers bounce, and the odd ones, there's no exponent here, which means there's really what? There's really ones there, which are odd. Okay, so the t means to go through. Now, we have to talk about the end behavior so that we know which direction the arrows are going. So if we were to window this a bunch of times, which we're not going to do, we just need to look at what the biggest exponent would be. So if we were going to multiply, this x minus 2 squared just means we have x minus 2 times x minus 2. And then we're going to multiply by x plus 1, and then we're going to multiply by x plus 3. So what would the biggest term be? What would this exponent be if we were to multiply them all together? Yes. You're just going to get these two x's, another x, and another x, which is a total of 4. Okay, so your end behavior, remember, is only determined by that biggest term. So let's think back to our last section. The exponent on this term is even, so that means what? They're either both going up or both going down. Remember, even ones go in the same direction, the arrows. Okay, what tells us whether it's going up or down? So out front, it's positive. So that means they're both going up. So now we know this. We know on the ends, they're both going up. So we do that. On those dots, on the far outside ones, whatever they happen to be, they're both going up. Now we look at these b's and t's right here. So it's going to bounce at this location. Okay, so that's over here on the right. It's going to bounce here. So this is what it looks like. Instead of going through that point, it bounces up off of it. The other two go through the point and through the point. If your curve, wherever it goes in the middle, doesn't match up with your ending behavior, you know you did something wrong, and you go back and redo it. Okay, so a recap here. We put our dots on first, those green dots. Then we look at the ending behavior, and then we do our bouncing and going through. We're going to do the same thing over here on the right. Okay, so let's put our dots on here. Where are we going to put dots? 0. All right. Now we need to figure out what is our first term. If we were to window all of this, which would take forever, and we're not going to do that. So we're just going to look at the x's and what the exponent would be. First of all, it's going to be negative because of this negative out front right here. Okay, what would the exponent be on it?
5.
No. If we were going to multiply all of these together, what would the exponent be?
10.
We're getting closer. I think I heard somebody say it. 11. Where are we getting 11? What's right here? There's a 1. And then we add 2, and then we add 3, and then we add 5. So you add all of those up. Your first term would be x to the, or negative x to the 11th. So tell me what we know because of this. The odd right here means what? Not going down. What does the odd tell us? Opposite directions. The arrows are going to go opposite directions. What does this mean? It's going to be like it's a negative sloped line going downhill. Okay? So knowing that, that means that the ending behavior is going to look like this, where if you would bring those two green arrows together, it would be a negative sloped line. Okay, now we're going to do the bouncing and going through. So looking at our equation right here, the odd ones go through. So we've got going through. This one's going to bounce. Going through, going through. We're looking at odd and even on the exponents. So the only place that it's going to bounce is on the 2, right here on the right. All the other ones are going to go right through the dot. Okay, so we're going to bounce here. We're going to go through, through, and through. Do not cross the x-axis unless you're going through one of the dots you graphed. Okay, that's one of the biggest mistakes is kids will, for some reason, get the ending behavior wrong maybe. And they're like, oh, well, it's not working with my bouncing and going through, so I'll just draw something over here to make it work. Okay, not in this situation, but don't cross through the x-axis unless it's on one of those dots that you graphed. Yes?
How do you know which way to bounce it?
So if you're down below, it's going to stay down below.
Okay.
And if it's on top, it's going to stay on top when it bounces, like a tennis ball.
Bounce up through the other ones. Like it goes up and
Going right here?
yeah.
So this is going to go through the blue dot instead of bouncing off of it
Okay.
because the exponents on them are odd.
Yeah, I get that, but why does it go up? Why doesn't it just keep the straight line?
Like right here.
No, like that one goes up to the -3. Like why does it do that?
Because the graph has to touch all of these blue dots, either going through them or bouncing on them. So if we're traveling up right here, we know that we have to touch this blue dot next. So we have to travel towards it, and we're either going to go through there or we're going to bounce up, depending on what the exponent is. Other questions? That was a good question. Okay. All right, this we already know how to do. They put it in this section with some different ways of saying it. Put this polynomial in standard form. All we need to do is window this, okay? So this squared right here means that there's 2 of them. So let's start by doing the window just for that. So we've got x plus 3 and x plus 3. We're multiplying them together. This is nothing new. You've been doing this for years. So we got x squared, 3x, and 9. We combine these two. So there's our answer. We need to take this answer and multiply it by what we haven't multiplied by yet. So this is not a square window, it's a rectangular window. Okay, along the long side, we put what we just figured out, which is x squared plus 6x plus 9. And then we've got our x plus 2, or x minus 2, sorry, along this side. Now, whatever we get in here and combine like terms, then we're done. That's our answer. Okay, so if we multiply here, x squared times x, got x cubed, 6x times x, and then 9 times x would be the top row. Bottom row, negative 2x squared minus 12x minus 18. Now, we have to look at our like terms. So these two right here give us what?
4x squared.
Okay, and then these two.
Negative 3.
Okay, so our answer kind of lands on the diagonal, but not really. We've got x cubed, 4x squared, minus 3x, minus 18. Questions? We're not going to do this one because I think you guys understand what's going on. I just want you to write right here, distribute at the end. So the only difference with this problem, you would have the same work that you do up here up top, but you would have an x on the outside that you would have to distribute through to every single term. But just do that one at the end. Questions there? Everyone wrote that note to yourself? Just got one page left and we're done. Okay. This we have also done before. Okay, 100% the same. Okay, but we're going to revisit it because not everyone fully understood it. So these are the roots or the answers, and we're going to work backwards to see what it started out as. So if you remember, our first step is to just write x equals each of these numbers. And then we're going to get them all to be equal to 0. So we're going to pull the numbers over that need to be. So this one already is. We'll subtract 1 on both sides here. Add 2 on this one. And now we have our three things that we need to multiply together. Okay, so we've got so we'll window this, and then we'll distribute our x. So we've got x minus 1, x plus 2. Gotta yell at me if I'm going too fast. Put these together to be x. Here's our answer. If we distribute this x right here, just transfer it down here, then we'll have our final answer. So x cubed, x squared, minus 2x. Now I bring up the last one because I want to make sure that we remember what to do with fractions, because we want to get rid of that fraction right away. All right, so same first step. X equals 1, x equals negative 1, x equals 3/2. These two are just going to pull the numbers over, so we'll subtract 1 on this one, add 1 here. What do we do here? Yeah, we want to get rid of this fraction. So right now there's a 2 on the denominator. If we multiply both sides by 2, we got 2x equals 3, and then we can subtract 3. Now, we're not going to go through the last steps of this because I know you guys know how to window. Okay, you would window these two first, and then we would take that answer and we would times it by 2x minus 3 in a rectangle window. Any questions. So some of this is review. The graphing stuff is definitely brand new. But some of it is stuff we've seen before. We good to go on the homework?